Hi everyone, thanks for coming. Talks data science and agility at Spring and Nature where I work. My name is Charles Kubicek. So just a bit about me before we start. I've been a software engineer, that's my background, for about 20 years. During that time I spent 10 years in Agile, digital transformation work in companies like ThoughtWorks, Equal Experts. That's where I kind of learned a lot of these things from a lot of the people there. And I kind of pivoted a few years ago into data, as they call it. So I think during a lot of these kind of agile and transformational things, I kind of realized that data was neglected, yet it was so important to kind of improving users' experience in many ways. Spring and Nature, we have a lot of data, as you could imagine, a lot of data engineers, data scientists, and there's a lot of work to do, especially trying to work out where our cloud bill actually got spent on. So for the talk then today, I'll talk a bit about challenges that we have with data, the idea of shift left, how that comes into it, concept of data as a product, and then talk about how we can improve delivery possibly. So just a bit of scope to begin with. I guess there's three kind of outputs you can get from data science possibly. One is an answer to a question there and then. One is a tool, like a dashboard. The other one is a model, like a machine learning model that you can deploy and use in various applications. So in this talk, I'll talk specifically about the last two, a tool or a model, some deliverable that's deployed into a production environment. So let's look at challenges then to begin with. So I see three challenges I'll talk about. One is a hidden raw data handoff. Next one is data inconsistency that comes in. And then last one is a production handoff. So the first challenge, hidden data handoff. So this is a pyramid that I got from O'Reilly. It's a data value pyramid. So it talks about how data scientists can create value. So it begins at the bottom with raw records, raw information. And then that's kind of aggregated into charts. Charts can then be linked and related into reports. Reports can then be used to make predictions, and ideally, at the top, those predictions are used to drive actions and value. So that's all good. My experience, though, these two things at the bottom, innocent-looking things, collecting and cleaning, tend to be the most difficult, the most complex, the most time-consuming. Once these things are all done, the rest of it, there's a lot of tools, a lot of ways of working that can do those two, but really, without those two, it becomes very problematic. So this word collecting is interesting. To me, collecting is like Easter Sunday with your basket, going in the garden, collecting nice little eggs that are going to be nice and tasty. The reality for me, though, when I've been doing this kind of work, is more like this. It's a dump, a data dump, that's literally what it's called. So it's an extract from a database, kind of as it is, and it's up to you to figure out what's in it. So there may be some useful stuff lurking in there that is helpful to you. There might be a lot of rubbish that doesn't make any sense, random identifiers. There might be some scary stuff in there, like personal information, sensitive information with no link to how it can be used or even where it came from. But it is a handoff, right? This is the beginning of a process. That's where some information starts and it's handed off to someone else to figure out. So one of the worst things about the dump is once you've got it, you've got to clean it. You've got to clean the rubbish, which is madness, but that's what it is. So in general, these dumps can be useful for learning, experimentation. Like I said, there might be some useful stuff in there, but it's not really supposed to be used in production, right? That's that's a bad idea. I much prefer the term connect. I think we should be connecting to data instead of collecting it, right? Because ultimately we want to build some live deliverable that needs a continuous feed of information. So second challenge that I've seen is data inconsistency. So let's talk about cleaning again for a moment. So what is cleaning exactly? So it's filtering data out that maybe doesn't look right, formatting it, so dates, times, converting currencies, deduplicating data that looks like it's being duplicated, removing outliers, or correcting things that look wrong. So all these are kind of a matter of opinion. It's normally based on what someone thinks is right or thinks is a mistake. But the real trouble comes in this kind of situation here, where you have maybe a source system and two teams, maybe who are different parts of the business and maybe haven't even heard of each other, that are producing a model and reporting on the same information. Now, because they're unaware of each other, they use different assumptions while they're doing the cleaning, represented by the different colors there. And then that model, or whatever it is, goes into some dashboard, and the numbers are slightly different. Now, depending on who's looking at the dashboards, or who's seen both of them, and the kind of decisions they want to make, this could be quite a big problem. Not just in terms of they can't make the decision they wanted to make, but they don't trust the data that they see. They don't trust that the teams have done the right thing. They may not even trust the source system anymore. That's a problem. One of the things I might do is just ignore it, not make the decision. Worst case is create a third team to go and find the right answer. So the third problem is a production handle. So a while ago, when I was trying to figure out this whole data science and delivery thing, I asked someone, I said, what is, how do data science models get delivered into production? How does it work? And this is what they said. The data science process is like scientists creating a vaccine in a lab. They hand off to manufacturing, scale up, and deliver. And this was a picture of me after I heard that. So this kind of made me upset in a few ways. First one, it kind of assumes software works like hardware. It's like we have the, and I can imagine real scientists in a lab, right, working with real chemicals, real real people at the end of the day. They're kind of vaccines, go into real people, real manufacturing. It's based around hardware and those constraints that come with it. But yeah, I mean, in Agile, we're constantly rethinking our processes, right? Because we work in software. It's soft, that's the point. We can change how we do things. And the sort of message that I got from there was we just take all the constraints from hardware into the data science process and copy them, which is a bit of a shame. The other issue that I had with this is that scaling machine learning models is as hard as developing them in the first place. So there's a nice diagram which captures this quite well. So this is in a paper from a while ago now, a Google paper in 2015 called Hidden Technical Debt in Machine Learning Systems. You see in the middle here, this is the machine learning code, and the rest of it is all other things that have to happen to run machine learning system in production successfully and continuously. So all these things have to happen for each model. So it's not like we can simply just create this model and hand it over the wall. The data scientists still need to be involved in some of these things here. And in the meantime, a lot of the cloud companies and other companies have tried to automate as much of this as possible, build services to do them, which is great. But some of these things, like collection, verification, still going to have to be done internally, because those systems that have generated the data that are kind of exporting them, their internal systems, and that work is never going to go away. So just to summarize a handoff, it happens too soon in the development phase. There's not enough context in handoff, and there's lots of data work still to be done once the model has been developed in that environment. So yeah, just a summary of the challenges: the hidden raw data handoff, the data inconsistency, and production handoff. So I like to overthink things a lot. So I reflected on this problem with the vaccine, and I thought, how can I explain this? What does a software vaccine look like then? Well, it's kind of like protection against viruses, and we do have software viruses, so maybe there is some thinking we could do here, could be done. So as you probably all know by now, if you kind of wear a hoodie, you put the hood up, walk into a dark room, sit down on your laptop, this person here, you become a hacker, right? And you're writing viruses, and you're trying to attack the companies we work for. And in the early days, the way that we defended against this was, once our services went into production, put firewalls around them. But the problem is there's loads of bugs and things that could be hacked in the services that we deployed. So one of the ways that we helped kind of get around that, or assisted with it, was this idea of DevSecOps, or AppSec, I think it's called now, I'm not sure. But the idea is to do the security analysis different phases of the development cycle. So at each phase, we're thinking about security in some way. While we're developing, I'd be thinking about SQL injection attacks. During testing phase, there's automated tests we can put in. So this concept is called shift left and works quite well. So yeah, I mean, maybe shift left is our software vaccine at the end of the day, right? We're kind of like protecting against risks by implementing a process or tools early as possible in the development chain. So what does this mean for us with data? Let's get back to this. What does shift left look like? So to use our dump and clean that we were talking about before, what we've got is a producer and a consumer. And the producer is handing off information or data to the consumer. Maybe there's some automatic dump going on. And the cleaning is happening over here. So what if instead we shifted this left, and instead the producer, instead of just doing a dump, did a bit more of a mindful export and then transform. So the consumer had a bit less to do. They still might do some cleaning, but actually the producer, with a bit more information of what a consumer and other consumers need from their data, could also do some of the cleaning and do it consistently. Also, the producer could then even go to the left and do some of the cleaning up front as data is being acquired. Like if you were here for the last talk, that's what it was talking about. How can we make sure that user interfaces give us the best chance of acquiring good data in the first place? So this kind of concept is kind of part of data as a product, which I'll talk about next. Has anyone here heard of this idea of data as a product and data mesh? A few people have, good. Has anyone like used it in an organization? Yeah, good, excellent, okay. So I'll talk now a bit about how we've been using this at Spring Nature. So data as a product is standalone data that is designed for consumers, and this is the big flip here. Instead of just having a one-off database dump, which is like zero effort, this time we're putting more effort and trying to understand what people downstream in the supply chain are actually doing with our data. So some of the attributes of data products are that they're discoverable. You can find them. You don't have to hunt around and guess which teams might have the data you want. They're well described, so it's clear what you should be using and what you can't use. They're interoperable. That means they can be used easily with other data products. We'll get onto that a bit later, but what it involves is a shared place where all the data goes, kind of like a warehouse. And things like identifiers that can link between data sets. It can join them easily. They are secure as well, so it means that any personal information in there can't just be made available to anyone. If you want access to it, you need to go through an access control system. And ideally, with those things and a few others, they're trustworthy. People can trust the information if it came out of a data product. If they know a report or something was made from a data product, then there's a level of trust there. So data as a product is data which is extracted out of some source system and then published on an analytical data platform. So this is kind of another way of saying something like BigQuery or Redshift on Amazon, or something like Snowflake, a kind of modern data warehouse type system. But one of the key aspects here is that it's owned appropriately. What I mean by that is that the team which acquired the data or own the system that acquired the data or generated the data, they export the data onto the data platform and it remains theirs. It's still their responsibility. Even though it's gone onto a different system, it's almost like an extension of their ownership remit. That's a really important part. It's not a throw over the wall style situation. There are standards involved. So how it's published, there's standards around the system that it goes onto, and also which sorts of identifiers are used, and also standards around metadata. So as data is published, there's metadata around the entire data product, individual fields in there, just basic stuff around which team owns it, how to get in touch with them, how you get access to it, where the source code is, things like that. And all those kinds of things help with trust because it's giving some, trust indicators, as I call them, to the data. There are data contracts. So as data is published, there's a conversation with consumers and there's an agreement reached about how the data, when it will be published, for example. Certain aspects of data quality can go in there. How the schema is evolved. These are kind of like agreed up front so everybody knows, the producer and consumers know exactly how things are going to be updated. Quality is observed. So this is like a system which is continually checking to make sure that constraints in the data contracts are met, and if they're not, then it raises an issue that can be fixed. So it's just checking to make sure data has been delivered and that fields are in the right format. This is quite a new thing. I think it's quite a long way to go because it's not clear sometimes if there's a problem with some data, exactly like what the consumer should do. If there's a fault, do they not ingest data? Is there a batch which they just leave, or do they just take part of the batch? It's kind of up to the consumer, and that's a bit of a tricky one. Also, the usage is monitored, so all the queries that are being run against data products and who's been running them are saved, and we'll get on to what we can do with that information later. So in data products, the generating team, I put a star there because it may not be the team, we'll get into that later as well, they transform the data for use. Why then? Well, it's because they acquired the data. They understand, like how it was acquired and what constraints were there. They understand all the nuances, so all those edge cases. There might be a reason for them. That's probably worth knowing. Things like duplications, maybe they're for a reason. They have existing processes already, but it's probably someone already using the data, maybe. So it's probably quite simple to kind of like fit something new into it. And they care, or they should care, how data is used elsewhere in the organization. If someone's like has an idea, they can probably talk it through with them to see if it's like possible or even legal with the data. So, just an example to go into some details about how these data products actually work a bit under the covers. So imagine this example. We have two source systems. They're both exporting their data as a product, as represented by the hexagons. Then on the right here, we have a predictive model that's being used. Say it's generating recommendations for this user-facing application. And then the user-facing system is also using some data from this product as well. So first of all, let's look at the ownership boundaries. So there's three ownership boundaries here. As I mentioned, there's the source system. Data product one is owned by the same team or the same group that owns the source system. It stays their responsibility. Same with the second one. And on the right, we have consumers who are consuming those two data products and then using them for their work. So let's kind of go down inside this data product and see what it is. So we have this kind of data pipeline, as it's called, going from left to right. So this first step here, going from source system one into landing raw, this is almost like the raw export that I talked before, the dump. It goes into there. However, it stays private to this pipeline. Remember, the pipeline is owned by the same team or the same group that owns the source system. It's still their thing. So it's fine for them to dump their sensitive data in there because no one else is going to see it. From landing raw, it goes on to staging, and staging is probably like the canonical complete view of the data product. So in between raw and staging is where all the transformation happens. Now, ideally, if we're going to be creating a metric that people care about, we want to have some standard which defines how that metric is calculated. So in the source system, we're taking snapshots over time, or maybe it's a change data capture, a continuous feed of information. But we're taking raw data in, and we're trying to create this kind of like historical view of what's happened in this system. And how that's calculated should be standardized, so everybody knows this standard means this, and that can be used in the calculation, and it should be totally transparent. The source code of how that happens should be open. Open to the company, I mean, not open. And then on the right here, we have various views. So these are kind of like views of the data product that have been designed for different consumers. So one consumer is going into some other live system, so we might transform the data or aggregate it in a way which actually looks quite different for what that application needs. That's what we've ended up doing. And then some of it goes out back into the like the warehouse style system, ready for other people to use. So this kind of term in the data mesh terminology is called an output port. So this is kind of like the kind of public-facing part, and there's quite a few kind of things that are attached to this. I'll talk about them now. So first thing is a data contract, like I mentioned before. There's a link out to what people can expect who are using it. There's usage that is continuously measured about who's using it and what they're using it for. There's metadata, which is published through into a data catalog. And then finally, secure access. So access is granted on the output ports. So from these things here, we can also do observability. So the observability system can be measuring data quality based on rules that are defined in a data contract, and those rules and how they've been broken and then fixed can be stored in the catalog. Again, those help us understand if we can trust the data or not, because we can see the types of issues that have happened and how quickly they've been able to get fixed as well. Data issues happen all the time. I don't think that's a bad thing. It's more about how the team's able to respond and fix them, which is important. And observability, that all goes into the data catalog. And the data catalog is like a tool open to everyone in the organization who can go on and they can search for it. So they can browse by entity or by department or something like that. And they can find what data products already exist. They can define who's using them, looking at the usage. They can define what other things like dashboards are using the data product as well. So ideally, a lot of what's already been happening in the organization is open to people, and that's helpful, especially in organizations like ours that are very large and quite siloed. So then, what we've got at the end of all this is not a data dump, but more like data treasure. We've been able to kind of flip this from something which was potentially reducing value into something which is more valuable. So this is great. It's not without its challenges though. I'll talk about some of these next. So incentives. Actually, sorry, I'll just pause for a drink. So you could imagine walking up to a project manager or a product owner and asking them, while you're busy building your service, could you also export your data as a product and do all these things? So responses might vary, depending on what you get there. And I think, it's quite tricky. And I think the reason is because talking about data products is different to talking about an actual software product that you deliver to your users, because data is very abstract. It's hard for non-technical people to understand exactly what it is, and from that, how it produces value. So one of the things I think is important is to take a leaf out of data science and data analysts and to look at storytelling with data. So we need to craft our own narrative with real data to continually demonstrate to people why this is a valuable idea and what we get from it. So one of the things we started doing recently is to look at all that usage data that we started collecting. It's called lineage data, and then putting it into something useful. This isn't it, by the way. This is just a demonstration of what our data lineage graph looks like. As you can see, it's a mess. It's quite chaotic. But in here, there's some interesting things we can already start to see. So I don't know if you can make it out, but some of these nodes are actually squares, and they represent data products, or those output ports, and the circles are intermediary steps. So you can already see that some of them, like that red one there, has a lot of kind of data coming in. This green one here has data going out. So there's something interesting there that's happening, right? There's a story to tell around why so many people are using that thing in particular. The different colors represent different cloud projects, which roughly relate to things like teams or even whole departments. And that's also something interesting to tell as well. If we zoom in on this bit here, we can see that coming from the green bit there, there's actually a lot of different projects or, teams or departments using that data. So that represents data that's moved across silos in the organization. And that's valuable. That's something people want to hear about. We've been able to kind of do that integration, which has normally been quite problematic. So this is good. So in terms of teams, what we've seen doing data as a product for a few years now, there's roughly 3 types of teams that we've seen evolve. The first one are existing product teams that start delivering their data as a product. For them, it's almost a natural thing to do. It's like they have a product, they have an API, and data as a product is another kind of interface that they kind of deliver to. So it's fairly natural for them. They're kind of natural owners of the data because they typically collected it as well. I guess one of the challenges there, though, is they may not have a data scientist on the team. So a data scientist or someone else will kind of pick the data up afterwards. That's fine. It just means that the feedback loop is maybe a bit more convoluted. The other thing we've seen is a whole team set up to deliver data as a product. So this is important for key data in our organization because it's if there's complexities around it, but we have to get it right, it needs a team almost to be looking at it all the time. and to work with all the other teams around the organization for their use cases as well. So you have a whole team of data engineers. That's great because in that team, you can also build it to include data scientists, data analysts, and then we have almost like a cross-discipline data team that can be producing the data, but also using it themselves to build like those deliverables that I talked about. And finally, there is domain data teams. So this is like a domain in an organization made up of multiple teams, or a department you might call it. So they are like delivering data as a product on behalf of the product teams. So this is just what we've seen where we just haven't been able to get enough people to kind of like have like more data engineers. It means that there's not a closer link as to how the data was acquired, but there's still, we found a good enough link, and this is actually a good enough way of doing it, actually. Yes, so just a word of warning on this data as a product idea. This is a survey from the company DBT. So they asked people about moving towards this like decentralized architecture where we're pushing all the data processing out to the side. And it turns out that this is quite common for company size. The company size is on the bottom here. So large companies are doing this already or looking at doing it, where small companies haven't got any interest. And that kind of, I think, is about right, I think. So one thing there to look out for. So just a summary with data as a product then. So data as a product can be used for reliable data connectivity. So it solves that collecting problem that we had earlier. Teams close to the source transform the data, and that goes towards solving our clean problem. And data transparency increases trust in data and with it its value. So we don't have that horrible situation where someone's asking for, another source of truth. It's like by doing this, we can maximize what we have because people trust it. Okay, I'm going faster than I thought I was going to. So I have to slow down. Okay, so talk about delivery now. So in data science world, roughly speaking, I guess there's 3 different things we could deliver or that people talk about as deliverables. One is notebooks, one is machine learning models that we've kind of learned and serialized, and one is like machine learning models as APIs. So off the bat, I don't think a notebook is deliverable. I think they're very good for discovery and examples, sharing information, even whole like reports. You can build them in a notebook, and it's great because people can get into the weeds and see how things are done. But you can also misorder execution of cells, and it can get messy quickly. So yeah, I don't think so. I think for models, it needs to be kind of like deployed as part of some automatic reproducible process. Again, that can be kind of trusted and verified. So yes, for deploying machine learning models, the industry has broadly come up with this idea of MLOps. So I borrowed this from this website, mlops.org, which is pretty good for talking about it. So it gives 3 main parts to it: the design of machine learning model development, and then operations at the end. So design is like requirements, use cases, an availability check. I'm not sure if a check is enough, but fine. Model development, which is data engineering, model engineering, testing, validation. It doesn't say anything about data science there, but I mean, it's in there, I suppose, with the model engineering. And then operations, which is deployment, pipelines, and then monitoring, triggering. So I know they mentioned data availability check, but I think data needs to be in here as something which is part of the process. And on the other side, operations needs to be, after the operations, there needs to be some integration, because you don't just want to deploy the model on its own, it's going to be used in something else as well. So I think that last one is a bit of a challenging handoff, actually, because if we're going to integrate with existing services that are backing our apps, we're probably running it already in some microservice platform or something similar. So which operations environment does it go into? The microservice one, or is there something else? We have 2 environments. Also, the other thing is like there's unpredictable costs here, because some of these machine learning models tend to be resource hungry, very resource hungry actually in terms of memory and CPU, because they're doing inference at request time. However, I don't think this is the only option. So one thing we do quite a lot with Spring Nature is build these like data APIs. So what I mean by a data API is that it's some API which it's just used for returning data. It's not transactional. We're not writing to it. It's just ingesting data from somewhere and exposing it as an API for people to use. So one of the principles that we use when building these services is that we should minimize the amount of compute work done at request time and move everything again back left to the ingestion time. So when data comes in, we do all the processing we need to do. We understand what our users want from the API, and we're literally transforming the data almost to the point where the output is what the user is going to be getting when they request the API. So there's almost nothing to do at request time. They're just pulling data out almost. We might have to change the format a bit to match if it's REST or something else. The same with search results as well. So from that, what it means is we get an API that's very fast. It's very simple because there's not many moving parts. We've reduced the compute at runtime because we've moved it all to the ingestion time. So, and also because of that, the failures are handled in advance, so we get quite a resilient service. So taking these principles and moving into our machine learning model, what is it that we can pre-compute? What can we move further up the MLOps chain? Well, if we think about it, this is what the kind of workflow looks like, very simply at least. We have our data, we train a model, we test the model, and then the model gets deployed in production, and this green thing here is our production environment. But what if we kind of change this again a little bit? What if instead of deploying the model, we apply the model to some data that we bring in, and we deploy data instead of the model? So imagine then, if we are trying to build a model for recommending something to our users. So for each user, we want to build some recommendations. So that's a finite set. We know who our users are. So when we're building our model, we can choose an algorithm which maybe takes into account what all of our users have done. And then we will build that model, and then we can apply the model to each user offline. Now, depending on how you do it, this could be done without using much CPU time. And as a result, the output of that is a set of recommendations for each user that is active on our website. And it's that we deploy. Now, we can run this once an hour, so it won't be like live recommendations, but actually, I'm not sure every website needs live recommendations. I'm sure we can kind of live with an hour's delay. One of the problems there, though, of course, is that they'll see the same recommendations all the time, but we can choose 10 recommendations per user and choose 3 at random to show them a different list. There are ways of getting around this expensive request time compute for machine learning models, I think. So in summary, not every problem needs real-time machine learning, I don't think. I think we can kind of move some of that work offline. We can move compute up to the left if possible. I think that's doable. And we should keep user interactions as simple as possible. I mean, I understand this isn't going to work for real-time things like LLM chatbots, but I'm not sure how applicable LLM chatbots are to that many problems. Okay, so I finished a bit early, actually. I hope you don't mind, but we can ask more questions. So here's some takeaways just from what I've talked about from this. So yeah, we should treat our data as a product. We should shift data responsibilities to the most effective point in the data supply chain, like the cleaning of the data. We should use standards and transparency to increase data value. We do that by increasing trust in what's happening. We should calculate key metrics once, close to the source. We should reduce compute done at API request time. And we should ideally treat the delivery process like science experiments. We can try things, we can change things. We shouldn't be limited to what has come from science. So that is it. Thank you for listening. Please give me some feedback there, that would be great. Thank you.
We've got 10 minutes for questions. Doors.
Yeah, go on.
In this affair, laser.
Yeah.
That's just that it's products. Yeah. but you said that saying to the turn it. What did you say? They their next response. Like evolving.
Yeah. It's a bit of a tricky one. I think putting more and more work onto that team. Yeah, that's when it goes down to the team size. Ideally, I think then it's about saying that it is best to process data sort of close to that to source. So the team should be taking on some of that work. I would say the team doesn't always want to. That's fine. That does happen as well. But the thing is, if they don't, then you get the data, you get that problem again, where the data is being processed in different places. And that is real in our organization, right? That does happen. And so that is the solution to it, is to move the work close to the source system. But yeah, I mean, then it's a question of like data engineering capacity. Then it's like, well, if you want to do that, then you've got to hire the people, and then that's a different problem. Someone else had their hand up, I didn't quite see. Yes?
Still like, yeah.
Yes, yeah. Right, well, it's not that easy. So I mean, the way that we've done it is my vision for this right early on was that we should make all data open and everyone can see it. And when I actually got close to reality, it's like, oh, hang on a minute, we can't do that. So first of all, we have to make sure that ideally humans don't see PII data. That's kind of like where I want to get to, and it's only like machines and automated processes that can see that information and then send it on. I think what's tricky are things like deletions. I think, like deleting sort of data over time. It's quite complex for us because we maintain a scientific record, so we do actually have to keep some data. But yeah, I mean, that's part of the kind of data life cycle, is that we have to go in and remove some parts of data, especially if if time has come or if someone's asked to remove it. But this whole kind of idea is supposed to make it a bit easier to do that, because we should be able to know through the catalog where PII data is if it asked to be removed. Yes, at the back.
Only do like this, but and the fact that it can be if I.
Yeah, so data literacy is quite a challenging one. I think it's something which we have to kind of try and introduce organization-wide. But I think that's where the data contract comes into it. I think what we do at the moment is when we can use our lineage graph, like I showed before, to understand like hotspots of data. I mean, we can talk to the team who's involved and like find out what they're up to. That's kind of like so useful. And then that's where we can introduce them to the idea of like ownership of data and what the responsibilities are. And it's super interesting because for some teams it's very natural to them. They're like, oh great, I'm just glad you gave me the framework. And other teams are like bewildered, like, oh, we didn't know we had this responsibility. And so that's when we can kind of like introduce like the sort of coaching of it. But yeah, data ownership is a hard thing actually, especially for vendor products like Salesforce, things like that. People don't naturally think of the data inside it; they just see the processes. So yeah, it's different depending on the source system and the department. Yes.
Is the like the but still active or more or website for?
So in some cases when we started out, we just knew that some data was going to be valuable. And so it was like, right, we need to get some data engineers and we just need to do this. Yeah, what has been happening now is that, yeah, it's been kind of surprising. We've seen like teams spring up who want to use data and all of a sudden find it really hard because like the data quality is quite poor. And we've been caught off guard as like an organization. So yeah, then we have to try and figure out, well, we actually need to be hiring people closer to the source system who can kind of like figure out how to get standards into it to sort of improve it. So it's quite unpredictable and it's a bit of a mishmash. What we just try and do is mediate between the different kind of like producers and consumers, which sometimes we can do and other times we just can't. We just don't have the people, but we do our best. Yeah.
With we get structure. Big top. Because the well, if you give that a fundamental secret team that the way so say they
It was, yeah, I mean, that's like the chicken and egg problem, which comes up all the time in data. As usual, we started with a spreadsheet, and we just kind of like got down between two teams, like what do you need from each other? And just getting it to one spreadsheet was hard, actually, to get people to come to the same place. So for data contracts, the infrastructure is still spreadsheets, actually, but we are using, we just recently started using some infrastructure to do the data quality testing. And that's because we realized that we're at a point now where we could scale this up. We have like 40 or so data products, and we think, oh, it's worth doing this now. And we're still trying that out. There's one more question? Yes.
Oh, check that date. There.
So in terms of technology, I mean, we're kind of like constrained by our kind of cloud, which is, mostly Google Cloud. And so we basically built on that. And we're such a small team, we're just kind of using what Google has given us and then introducing standards and explaining to people how to use it. So we get, regardless of what technology is used in the source systems, we ask everyone to export onto Google BigQuery, in most cases at least. And it's like, from there they can build their processes using things like DBT, for example. But really, I'm not precious on technology choice. As long as the data has been exported, it's got the metadata, it's to the standards, that's the important bit. Yes?
One criticism I've heard of data mentioned in the products is that because the focus is on the individual data source, both from the Zoom reporting, like you mentioned, that eventually leaves the gap with like where you're actually using the data, is that you use it across all those things, so that the even scaling.
Yes, it is something we've experienced. We put a lot of effort in getting the data shared, and we realized we neglected how the data is consumed. So yeah, we suddenly realized that we need to put a lot more effort into like data architecture, I suppose you could call it, so to stop like the spread of too many things. And that's something we're dealing with at the moment, because we sort of, yeah, it's a really hard problem, because a lot of people want to get involved. You've got architects, enterprise architects want to get involved. People want to come with models, things like that, and it's all interesting, but it's like, right, we need to try and simplify this as much as possible. Ideas when people talk about product, user, it's kind of obvious like what set of data products to use, or maybe what kind of like aggregates people are using. That's, yeah, it gets messy actually quite quickly. Yeah. Right. That's a good question. Yeah, so we tried quite a few data catalogs, but I mean, we wanted to get a nice curated set of data products people could trust, but a lot of them just seemed to be just throw it all in and we'll make sense of it, and they were horrible. So what we ended up doing was building quite a simple web application, which is almost like a sort of integration system. So it's quite simple, but it's going to BigQuery, going to other systems, pulling out information. And we just spent a lot of time talking to users around the company, so different types of data people, to figure out what they wanted to see from it, which was interesting because what they wanted was different to what the products in the market were offering. Because you found the same thing. Yeah, so that's where we just opted, I work with a few software engineers, and really good ones who, actually built a data catalog. And yeah, as it gets bigger, it does need more curating. We need to introduce more concepts into it, but it's all about presenting something that people can trust and want to use. But yeah, it's been great. I mean, people want to put their data in the catalog now, which is great.
Thank you very much, Charles.
Thank you.